we're just doing the power rule, so we're multiplying the outer exponent by the inner exponent, and we're keeping that base the same, right? So if I multiply 3 times 4 on my base of 7, gives me 7 to the 12th power. Now if I multiply 3 times negative 2, what do I get as a new exponent there? What's negative 2 times 3? 6? Negative 6. Is this going to be my final answer here?
1. Put a 100.
That's right. We got to continue to simplify this. We don't want to leave negative exponents in our answer. So like Nick said, we'll put it over 1. What are we going to do now? Flip it and make the negative a positive. So we get 1 over 7/6. 7 to the 6th power. Same thing in number 3. We get 8 to the negative 12th. That turns into 1 over 8 to the 12th. We're going to go kind of quick on this because I know you guys know how to multiply. We'll spend more time on 17. Number 4, nice and positive, we get 2 to the 12th. Number 5, we get 7 to the 12th. I didn't realize there were so many 12s here. 6, we get 8 to the 8th. 7, what's negative 1 times negative 3? What is it? Well, what's 1 times 3? 3. And what's a negative times a negative?
Positive.
Positive. So it's just 3 to the 3rd, or 27. For number 8, we get 8 to the negative 16th. Put it over 1, flip it around. 1 over 8 to the 16th is our final simplified answer. For number 9, we get 5 to the 9th. And number 10, we get 3. Again, those double negatives cancel. And we get 3 to the 3rd. Or 27. And what you'll notice is number 7 and number 10 are basically the exact same problem. Except our inner exponent and our outer exponent get flipped around. But still, because we're multiplying, we end up with the same thing, right? Any questions on the front here? Everyone, anybody get all those right? Yeah? Very nice. To the back we go then, very quickly. For 11, 2 times 3 gives me 6 to the 6th. 3 times 3 gives me 7 to the 9th. 0 times negative 1. What's 0 times anything, really? 0. And what's anything raised to the 0th power equal to that we talked about yesterday? 1. Keep that in mind for our quiz today, okay? Anything raised to the power of 0 is equal to 1. For number 14, we get 4 to the 6th. 13, we get 3 to the 12th. 16, we get 5 to the negative 16th, which turns into 1 over 5 to the power of 16. 17, we get 1 over 4 to the 4th, because we get that negative, we got to flip it. But again, I've got a double negative in 18, so that multiplies to a positive. 8 to the power of 8. Number 19, I get 6 to the negative 6, which turns into 1 over 6 to the 6th. And finally, 2 to the power of 6, which is equal to 64. 2 times 2 times 2 times 2 times 2 times 2. 8 times 8, boom, 64. Any questions I can answer on the back? All right. Put that to the side and take a look at 17 now. 17 is where it gets a little bit trickier. So on worksheet 17, the first 8 problems are all product rule. What very tiny detail in all these problems tells us that this is the product rule? N? Not necessarily a letter, more so I'm looking for a symbol. What tells us that we're looking for a product here.
I meant, the dot.
The little dot. Because what does that dot mean? Multiplication. And what do we call the answer to a multiplication problem? The product. Okay? So when you see that dot, you should think product rule, which means you're going to do what with the exponents? Add them together. So in number 2, what number is really in front of this v that we just can't see? 1. So my numbers in front are 1 times 10, and I'm going to add my exponents together. 1 times 10, and then I've got my like bases that I add together. That gives me 10v to the 5th. Again, if we expanded this out, right? 1 times v times v times 10 times v times v times v. How many total v's do we have here?
5.
1, 2, 3, 4, 5. And my numbers are 1 times 10. What's 1 times 10? 10. Same answer, right? So this product rule that we use where we just add the exponents together is just a shortcut for expanding all this out, right? Now for number 3, I take my numbers in front. What's 10 times 7? 70. And then I take my powers of n and add them. What's negative 1 plus 4? 3. So I get 70n to the 3rd power. Number 4, I take my numbers in front. 3 times 3 is 9. What exponent does this a have in front? 1. It's got invisible 1. So what's 1 plus 4? 5. 9a to the 5th. Again, I have an invisible 1 in number 5. 5 times 3 is 15. 1 plus 3 is 4. Does that look right? Number 5? No? What's wrong with my answer in number 5? I'm missing the m. And I saw this a couple times yesterday. We're forgetting about the variable. These product bases have 2 components. We've got a number in front and a letter that's housing this exponent. So we can't just throw the exponent on the number. The exponent has to stay on the letter, and that number has to stay in the front. 63v to the 9th is what we get for number 6. 18n to the 3rd is number 7. And 30x to the 10th is my answer for number 8. So double check your work and make sure it looks like that. Your answers are all good. Now looking at the problems in 9 through 12, what rule do we have to use here? Are we going to use the product rule again and add our exponents? Or are we multiplying anything here? What does that line tell me? We're dividing, right? So this line here tells me that I'm dividing these 2 product bases. So that means I'm not going to add my exponents, I'm going to subtract them. Now, like we said yesterday, it's actually easier for us to expand everything out here, cancel what we can. If we do the quotient rule as it's, as we learned it, we're going to end up getting things all mixed up. So let's expand this out. On the top, how can I expand out the number 2? 2 times 1. And how many r's do I have on the top? 6. On the bottom, how can I expand out 8? 2 times 2 times 2. And I've got 3 r's on the bottom. What pairs can I cancel out now? Pair of 2's go away. What else? 3 pairs of R's. On the top now, I've got a 1 with 3 R's. On the bottom, I've got 2 times 2, which gives me 4. Do I need to write that 1 in front of the R's? No. So we end up with R cubed, or R to the 3rd power over 4. Number 11, 2 times 5 with 4 A's over 2 times 2 with 2 A's. Cancel out the 2's. 2 pairs of A's. What are we left with on the top? 5A to the power of 2. What are we left with on the bottom? 2. Nice and easy. Number 12, 2 times 3 with 4 M's. On the bottom, 2 times 5 with 3 M's. What can I cancel here? 2's and 3 of my M's. So on the top, I got 3M, and on the bottom, I've got just 5. Maybe I accidentally canceled the 3, but that's all right. 3M over 5. Great job. Very quickly, these last 4. We're going to end up with 2n to the 3rd. Nothing left on the bottom. Number 14, I'm going to expand this one out. 3 times k over 3 times 2 times 2 times k times k times k times k times k. A lot on the bottom. What can I cancel out here in number 14? 3's and 2 of my k's. So 2 times 2 equals 4. And how many k's do I have? 3 of them. Is that my final answer? 4k to the 3rd? No? What did I do wrong, Princess? I forgot the 1 on the top. Remember, we can't just get rid of the numerator. If there's nothing left in the numerator, we have a 1 left over. Now, the same thing goes for something like number 13, right? Let's say if I work this out, 2 times 2 with all my n's here, 2 and all my n's on the bottom. I cancel out everything on the bottom. I still do have a 1 on the bottom. We just don't need to write it if it's on the bottom. If it's on the top, we do need to write it. Number 15, 1 over 4p squared. Number 16, 4v to the 3rd over 3. Does that look right to you, number 16? Yeah?
Yeah.
Okay. Cancel out a 2, 3 of the v's. Yeah, that's what we get. And finally, product base with these power rules. Again, I'm distributing the exponent to both my number in front and my base, my variable. So I got 2 squared, and I am going to multiply my exponents here. P to the 3 times 2. That gives me 4p to the 6th. Two squared times x to the 2 times 2 gives me 4x to the 4th. 5 to the 3rd times x to the 2 times 3. What's 5 to the 3rd power? Is that 15? 125. Great job. 125x to the 6th. What's 3 to the 4th power? 81. 3 times 3 is 9. So 2 of those, 9 times 9 gives me 81 n to the 4th. What's 2 to the 3rd power? 8. X to the 9th Good. 27b to the 12th. Perfect. And finally, there you go. Look at that. You guys are pros. 25v to the 6th.